So like I said, these labs will always look the same though. So always fill it out, read the reading, do the checkpoint questions. After the reading and the checkpoint questions is the actual lab part of this, of any lab. Now, last year you got to do fun stuff like cutting up dead animals, and that was super fun for some of you. To me, that sounds awful, but to each their own. For us, a lot of these labs are going to be working on some of the skills that we learned in class. So not quite as exciting for some of you as cutting up dead animals, but we will be doing some hands-on stuff with rocks and minerals. We're going to be doing weathering and eroding some things, but today's activity is kind of dull, not going to lie. We're just making a graph for this lab. So today's activity is right here. It's listed in the procedure. We do start with the objective always. So really like, what's the point of the lab? So you will see how graphing a natural phenomenon can aid in predicting future events. So you can hear in there two of the things we've been working on in class, graphing, and then using the graph to make a prediction. So we're just practicing what we've been doing in class. So for this activity, it does say to label both the X and the Y with the correct variables. Using the data given, plot the number of sunspots for each of the following years. Connect the plotted dots with a smooth line, and be sure to completely label the graph with the correct variables. I'm going to help you out, but I'm not going to do this for you. So I'm going to help you with some helpful hints. So my first hint is to put your paper landscape, so not up and down, but side to side. So not this way. I highly recommend going this way. Landscape, portrait, landscape, in case you didn't know. So that's my first hint. Now you have a blank sheet of graph paper, and I do apologize that it's like ancient and it's kind of faded. Did anybody get one that's so faded you can't even see the lines? Okay, it's gonna get you a new one then. So my other hint for this, because I've done it enough, knowing that you need a lot of space, let's go ahead and draw our y-axis first, and my hint will be just to count 2 boxes over from the edge of the paper. So I'm going to go whole boxes because my graph paper looks crooked. Here's 1 whole box right here. Here's 2 whole box. And then I'm going to draw my y-axis on that line. So we're not leaving much space. Now mine looks crooked, but that's because my graph paper is apparently crooked. And then same with the x-axis, I would only count 2 full boxes up from there. So there's 1 full box, 2 full box, and I'm going to draw my x-axis in. I think for next year, I'm going to order some new graph paper that actually shows up and isn't crooked. So despite the fact that mine looks terrible, it is nice straight lines. It's the paper that's crooked. Well, I mean, you're using a ruler and there are lines on the paper, but what I can see here is like, that's the box that's down here. And then up here, there's a full box. So it was legit cut in half or cut crooked. Anyway, that should be the easy part, just drawing the lines. Now notice I didn't go too far over to the edge. I didn't put my line right here. What would be the problem with putting my line right there? Yeah, there's no room to write. I will tell you again, why didn't I go like here? Because I wanted to give you enough room to write the numbers that are required. So we learned yesterday in class, and I'm sure Mr. Miga's been working on it too, that there's 2 variables, and we read it in the reading, even if you weren't here. There are 2 variables, the independent and the dependent variable. Which variable goes where? That definitely is not it, but way to go with the effort. Which one, the independent or the dependent goes on the X? Nah. It is the other way around, sorry. And I think that says that in here, the independent variable, AKA the manipulated variable, is the one you have control over or the thing you choose to change. In a line graph, the independent variable always goes on the horizontal axis called the x-axis. So the independent's going to go down here. The dependent's going to go up and down. Now here's the data. Now, first thing I want to say is see how there's 2 columns here, or actually there's 4 columns. What this really should look like, and this has confused people for years, and I should probably change it, but then it will take up so much space that I would have to use 2 sheets of paper, and that wouldn't help anything. What this really should be, and no, you're not doing this, I'm just showing you, is there's years 64 through 88. Here's 90. There's the rest. So it really should just be one really long data table. So when you get to 88, you're going to come up here and start over again at 1990. Does that make sense? Okay, so it's one really big data table that I just tried to fit in a small space. So we have 2 sets of variables. We have year and number of sunspots. So again, the independent's going to go on the X. The independent is the one I can control. Can you guys control the year that you take the data in, or can you control how many sunspots the sun shoots out that year? You can only control the year. You have no control over the sunspots. So years, and I probably should have let you figure this one out on your own, but I guess I went easy on you today. Years, go down here. Notice how I still left room to write. Oh, does anybody need a pencil, by the way? Technically, you don't have to have a pencil, but I know it would make life easier for you. So I got plenty up here. So years there, number of sunspots. What is the range for the years we have to do according to the data table? 1964 through 2016. Now, normally on graphs, we always start at 0. Would it make sense for this lab to start at 0 years and count all the way to 2016? No. So years is the exception to that rule that you don't have to start at 0. So I would recommend you could do one of 2 things. You could start, I'm going to just turn my paper to write better. You could start right at 1964, or you could start at 1960. I don't care which you choose. And then you need to go all the way up to 2016. Do you think you can count by ones? That's a lot of years. You might be able to, I'm not sure. Here's where I'm going to let you guys go on your own. I want you to, not that I want you to struggle, but I want you to figure it out on your own. Same with number of sunspots. What is the highest number we have to go to for number of sunspots? 165. So in that case, you do start at 0 and go to 165. So this is where I'm done working together with you guys. Mr. D.
There's a few tips. When you're putting your numbers in, whether it's the years or sunspots, make sure you actually find a box and put a number on the box. I've seen people put numbers in between boxes because the lines are so light. Okay.
So here's what, let me show you what Mr. D means. So he means, here's the line, write your year. This is what you mean. And then this one is going to be whatever year you choose to go next. So
you can write vertical too.
Yep, just like I just turned my paper to write and made it a little bit neater. Another hint, you don't actually have to write the 19 part. So you could just write 64 and then 66. Same with the 2000s. When you get to the 2000s, you can leave off the 20 part and then just do 00, 02, things like that. So see what fits before you start labeling everything though. Was that your only hint, Mr. D?
Yes.
Okay, perfect. It was a good one too. All right, so I'm going to leave you to it. You have about 15 minutes left. My goal is for you to have everything beautifully labeled before you leave. If you don't, we'll figure it out next period. But you don't have to keep going beyond getting it labeled. You don't even have to start plotting today if you don't feel like it. Okay? Let us know if you have any questions.